Mario, once again with MIA Microflight. In this video, I am going to explain how to test this C189 ESC board. The flight controller on this one has gone bad, totally bad. And I just placed this over just to give you an idea how to go about these things. Once you remove the case, you're going to be exposing, the two boards. One is a piggyback on top of the other one. The flight controller with the receiver is this board right here, and this one I done some modifications and some fixes. That's why these wires are kind of hanging loose here. But this would be the receiver flight controller board, so we don't want that. If that has gone bad, you're going to replace it. Let's say in this case, I am going to remove this and test just the ESC to make sure that the ESC is working just fine. So in order to do that, you need to know what these pinouts are. There are two rows of 6 pin headers. These are micro, the micro or sub-micro headers. They're not your regular headers. And here's the male of that header right there. So you're going to have to buy these headers. I believe these are spaced out at 2 millimeter separation. So, but these are the smaller ones than the regular ones that are used for prototyping and breadboarding. So 6 pin headers. And what I've done here is I've done a schematic of this particular setup right here. And I'll focus in a little more on this, but let me explain the components, the physical components. You're going to need a servo tester. You're going to need to make yourself this harness here, this wiring harness. This is nothing more than just a servo lead here, the 3-pin or three-wire lead connector that I connected to these headers. The way these headers are connected to this servo connector is you're going to need 2 of them are going to be black. The outer opposing 2 pins are going to be red, or your B plus, and the negative is your B minus. Black wire B minus, red wire B plus, and in between you're just going to join those 2 pins, as I've done right here. Let's see if I can zoom in on this right here. So here we go. So you have the servo, and then you're going to wire. You're going to need 2 6-pin headers. You're going to wire the signal to one of these, and you're going to join in pairs the outer 2 pins and then the inner 2 pins. And I'll explain why that is done so. Then the red is connected to that side. Notice that I have also connected the red to a little tiny switch here, just an on-off switch. And that is so that I can switch the B plus side with the inner 2 pins right there that you see there via the switch right here. Okay, so that's going to transfer the power from the battery that you're going to connect to the flight controller via either the original connector that's connected to the board, or in my case, what I've done is I made my own external connector so that I can connect my own batteries there. Just a 2S battery, 450 milliamp hour LiPo that I can connect it to the board. That bypasses having to use the stock battery. So the way this is connected is basically there are 2 pins here. One is this one right here, which is which would be that one, the black, and then the red. That's where your B plus and B minus, or B minus and B plus rather, is connected to this XT32 or XT30 connector that goes to the battery, main battery. And then don't worry about these other wires. These are the wires that connect to these connect to the tail ESC or tail motor rather, and these connect to the main motor, brushless motor. This one connects to the tail motor. They're both brushless motors, and these are the, of course, the base of the headers right here. Okay, so the schematic that you see here basically details what I just explained here. You have the board, the ESC board, with the headers. Remember, these two are connected together. These two are actually for the tail, and these two are actually for the main motor. You have your B minus and B plus connected to the 2S LiPo, and this board will not turn on unless you bridge these two with these two right here. And that's the purpose of that switch that I showed on this physical wire assembly, which I should also mark on my drawing here. So let me do that. So basically what you have is you're going to have a switch between that and that switch, on off a switch. Okay, and you can just simply look at this drawing and follow these the wiring traces here. This is the minus, which goes to the minus of the output side of this servo tester. Then of course the plus gets to the plus side here, and we're switching this on via this separate little switch that I showed on my wiring harness. And the signal gets connected just to one of these sets of two, which are also bridged. So if we look at the signal, well, they're actually bridged on the PC board itself, so you don't need to bridge that. But if you want to, you can bridge those two right there. And then to test each motor, what I do is I just connect it this way, and then I flip it 180 degrees to test the other side of the motor, because all you're doing is sending the signal from your servo tester to these points right here to test the function of the ESCs, as I'm going to demonstrate in my next step here. So basically that's your setup here. This side of the servo tester, I am just using 1S LiPo. Make sure that you connect this properly. Notice the plus and the minus. The red is the plus, minus, and so you have to connect it at the bottom side of this right here, like that. And this should turn on. And then for testing this, you want it on manual mode. Let me see what's going on here. What's going on? What am I not getting? Okay, there we go. So right now it's set up to manual mode. Make sure the connections are right. Signal at the top, plus at the center, and ground or negative at the bottom right there. Now I'm ready to plug this onto the board. So what you're going to need is, let me move this out of the way. Once again, there's the diagram. And now I am going to plug the battery to this XT30 connector. And you'll notice nothing happens because there's no, the board is not on. I mean, it's got power right there, but in order for this to turn on, it's got to supply voltage to the rest of the components, and the only way that does it is via the onboard switch on the flight controller, which is directly in contact mating with this connector here via the 6-pin connector. So we're basically mimicking in this wire harness with the switch this switching setup right here. Of course, this distributes also power to this board right here once this is plugged into that other one, but we're not concerned with this. We're only concerned with testing this, sending a signal to the ESC, to circuitry to test the ESCs to make sure that they work. And this switch is basically just just to bridge those two pins with the center two pins, which distributes power to the rest of the board. So that's what I am about to do right now. So make sure that the switch, if you know the position, is off. This one is off. I think it's that way. So make sure you connect this properly. Okay, and then the signal plug, I am going to test. I'm going to test a little rotor at the back. So that one is that one right there on that side. It's kind of a little backwards because you would expect that that pin would be next to this one, right? Would be that for that motor, but it's not. This one is for that motor. That one's for the tail. So I've already done this many times. So I know what I'm doing in this instance. Okay, so it's connected. I'm going to test the tail rotor, and but before we do that, we need to turn that on, and you hear that beep 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 beep. So that means that it's ready, and you can see using my servo tester. Okay, so that's testing one of the motors. Now I'm going to turn this off just for safety. That's the purpose also of that switch. And I'm going to reverse this plug right here so that I can test the main motor. Make sure you connect this properly before you turn things on. Make sure that everything's seated in its proper location. Come on, baby. There we go. Okay, so that's seated to test this main motor, and I'm going to straighten these blades. So let's see if we can shrink this a little bit so we can see what we're doing here. Okay, so now I'm going to turn this on again. Be careful, make sure you're holding the helicopter. You can also do this without the blades, preferably. Remove the blades so that you don't engage with the blades with your body. It's a lot safer, but because I've done this so many times and I'm very careful, I'm just going to do it this way. Okay. Turn this on. You'll hear the beep 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 beep. You know, the typical signaling that tones you get once the ESCs are ready to accept the signal, and there you go. And you see that abrupt, those abrupt interruptions right there is because these connectors are rather loose. They as far as the spacing is concerned, it fits perfect, but as far as pressure, you know, on the pins themselves, they're not very tight. I have a suspicion that all the issues that I had with this controller before it went bad, before I totally got damaged, you know, in crashes and in repairs, I have a suspicion that these pins themselves were not making contact properly with the ESC. Now, this board right here, I believe the two pins that are part of this connector right here, the two center pins, are for let me shut this off. Are for handshakes with this board. For telemetry or handshaking, you know, with the board, it's you know, to make sure that everything's running properly. Although all you need is just a signal, you know, to the ESCs. You know, as long as you don't have when you don't have the signal, nothing happens. When you have the signal, you know, the motors turn on. Basically, that's really the way it is. Really simple. But I have a suspicion that if this is not making proper contact with this board right here, because the signaling that I'm sending via this servo tester is actually sent by the flight controller via those outer pins for the tail motor and for the main motor, and for the tail motor, main and tail motor. You know, when you piggyback this on top of that. So if these connectors are rather loose, you know, you're going to have issues with the flight controller. Either you're going to lose connection for the throttle. The throttle may get may get stuck in a runaway or flyaways, it's a possibility. Flyaways are typically more an issue of the sensor, the gyro sensor, accelerator barometer than anything else. But if these connectors are loose, they're going to give you issues. So make sure that when you're connecting things, when you have a new flight controller, that everything is precise, and it doesn't move. I would go one step further. Of course, this is not for just anybody. It's more for somebody that's skilled in soldering direct wires to the boards. I would just solder, these connections here directly to the board, so that they don't. There's no chance of these things disconnecting. Having intermittent connections, because that's what happens when you have loose pins that fit loosely on these sockets, like these do. So what I've done here in order to maintain this a little bit tighter is I opened up these pins. I spread them out rather a little bit on at the ends. So, and then I just make sure that they realign, and that spread of the pins allows it to make better contact, and it doesn't allow it to move as I'm testing this. So keep that in mind. But basically, that's how you test these the ESC, and of course you have the schematic. I just gave you the pinouts. I did another video where I talk about this. I don't know. I did that a few months ago while working on this C189. And as you can see, the C189 is working just fine with as far as the speed control. So my plan is to either replace this with a newer one. I did come across some information that it said that that the new boards are dated 2025. I think somewhere around 2025. 2025. Yeah, it's a later board. This one is dated 8/11/2023. So this is some older board. So I'm hoping that the new board I did order a new board. I'm hoping that board will be much better and will not exhibit these flyaways. But I am going to. I think I'm going to make these connections a little more permanent, as I explained. That takes a little more work. Because now you have to solder, all these connections and not rely on these headers. That's one option. The other option is to just employ my own receiver. And basically, all I need is just a 3-channel receiver here. The mixing can be done on the transmitter if you have a nice programmable transmitter. Fly Sky, one of those 6-channel transmitters that do have mixing that allow you to mix, mix your do some swashplane mixing, and all you need is just a rate or heading hold gyro, for the tail. The rest is pretty much just a receiver, 6-channel receiver, a gyro, a heading hold gyro, to do the tail control, and that's, you already have the ESCs there. So that's that would be my workaround the issues with these flight controllers. I'm hoping that the new one will not have any of the issues that this one had, flyaways, runaways, and uncontrollable crashes, where you just can't control the throttle, when that happens. So if that works, great. Otherwise, I'm just going to go with separates like I used to do in the old school way when I started making my own RC helicopters. Of course, this is fixed pitch, collective pitch. Mine were fixed pitch at the time, but the mixing on the transmitter can be done, via the mixing curves for collective pitch settings, and all you need is just a tail gyro, just to keep it from wagging, getting out of yaw, and that should basically do it. The fact that this has 5 blades, it has an inherent stability. I did notice that. Let me demonstrate that once again. So I don't hear. Oh, I don't have the battery here connected. Beep beep beep. Okay, so when I say inherent stability. It's in the blades itself, because of this have a little bit of weight, and so that weight acts as a fly-by-wire stabilizer, a mechanical stabilizer. So if I increase the throttle here, push this away. Provided the blades are calibrated, they're both equal weight and balance. This thing is, you know, if you jerk it, it wants to come back to its own stable position, because of this gyroscopic stability inherent in the blades themselves, by the fact that we're using 5 blades instead of 2. So I don't think we need stabilization for the rotor, and that's why I said, you know, we can get